Jon, are you on?
I think I'm on.
Yeah?
Hello. Hi, friends. How are you? It was very lame
Asleep,
for a bunch of Australians.
Yeah.
Must have been a drinking party last night. Cool. Thanks for coming by. This is called Play-by-Play. This is something that I think Rob Connery kind of started. We were going to have actually a slightly larger panel. We're going to try to get Rachel Reese to join us. She's off doing F-sharp at an F-sharp meetup. So you're going to have to settle on Jon Skeet, who happens to be... what is this? This is your Stack Overflow.
This is my profile page.
Page. You
It's
have
close to
a meager 884,000 reputation, putting you as the #1 contributor on Stack Overflow. If you died, God forbid, how many years would you remain the top person on Stack Overflow as a corpse?
So I think I would probably hit the rep cap during the week.
You would still be hitting the reputation cap while dead.
For a while, at least. Yeah, during the week. So yeah, I get a load of votes even if I don't post stuff because I have a lot of I've got 33,000 answers, so that kind of gets.
You've lapped everyone else. You've basically. You look far behind, but you've actually got in Mario Kart. You're several laps ahead already.
I think over the weekends, within a year, I wouldn't rep cap.
That is brilliant.
But I've certainly hit the rep cap every day since June 2010.
Excellent. So I would encourage you to go out and Google for Jon Skeet jokes.
Facts.
Jon Skeet facts?
Yeah.
You're familiar with Chuck Norris, right? Our greatest American hero.
Yeah. There we go.
Chuck Norris is one of those great heroes where they tell jokes like, when Chuck Norris does his push-ups, he's not pushing himself up, he's pushing the earth down. There are a series of those around Jon Skeet as well.
These ones I wrote.
Users do not mark Jon Skeet's answers as accepted. The universe accepts them out of a sense of justice.
I think we should switch to K. Scott.
So, K. Scott changed his name to Scott to be successful in the Microsoft world a number of years ago. But it turns out that it's worked out really great for him because he is a top Pluralsight author and the author of a very popular blog called Ode to Code. And many of us learned ASP.NET from Ode to Code and from K. Scott Allen. So big round of applause for Jon Skeet and K. Scott Allen. Definitely go and check out their stuff, as well as a great, was it an article or was it an ebook on what you need to know about ECMAScript that you did?
Yes. Ebook. It's
ebook.
basically just for the Kindle.
So a Kindle book that he recently did on what every developer needs to know about ECMAScript. So check that out. OK, so the idea here is that Rob Connery, who's usually the person that plays my role, goes to Stack Overflow and picks hard questions, and then asks these kind people on the panel to answer those questions and what they think about them. So, and then wackiness ensues. So we have a series of questions. Why don't we bring up the first question, and we'll see how each of these individuals, go ahead and zoom in on that real tight. OK, a little light reading for us here. So what is the difference between running IQueryable of T versus IEnumerable of T? And then there's a very nicely written example there. And we'll both include deferred execution, right? There's that thing in LINQ where it doesn't really happen until it happens. There's a bit of a Schrodinger's cat aspect to LINQ that can be a little bit confusing. Who wants to go first?
Can I go first with a change to the question? I'm not actually, I'll edit this, I won't
You're going to actually edit the highly voted question.
I'm just going to, just to show.
That's exactly how I wanted to start this show, was you just going into admin mode on Stack Overflow, going, actually, the question is wrong.
The question is right, but this is not how you should write either of these queries, basically. So these are written as query expressions in C#, introduced in C# 3. And that's 3 lines long. And the equivalent of the first one.
I love that you're doing it in a text box without syntax highlighting, thereby increasing the legend. So
That's one of the great things about Stack Overflow is you get much better at being able to write code that will just work first time.
Really?
Without, yeah. Sometimes there are typos.
What is the
obviously,
little thingy that goes C and then an arrow? Is that an Anders operator, or what is that called?
Lambda expression.
That's called a lambda
Well, it's a
expression?
lambda expression here. It's not a lambda expression if you have C#6 stuff. If you have, so say we were in
You're
string.
going to write a whole app here. Is that called a hash rocket, or is that another thing?
No idea about
You
hash
never heard of
rocket.
hash rocket? I think that's a thing.
That may be a completely different
How do
thing.
you pronounce that? Public bool is even length, blah, blah, blah.
So I would just say goes to or
Goes to.
Meh. It's
You take meh.
But importantly, this is not a lambda expression. It's the same syntax as for lambdas, and likewise, if we did public bool equals,
Oh, is that a shortcut
Object
for
X.
curly braces and stuff?
yeah, it's a shortcut for curly braces with a return. So X as string, for example.
All right,
It's
cool.
just
They look the same, but they're
expression-bodied
different.
members.
They're different based on context.
Yeah, so lambda expressions are for delegates and expression trees, and this is really just a shorthand for declaring a property or declaring a
But we
a
all
method.
know, though, that if you do that in your code, it makes you look smarter to your coworkers.
So you say that, but it's actually true. So
Hang on, I just want
you said that slightly
I just want to
facetiously,
say,
but
the
it
way
is
that you
actually
said
true.
that was that you said that we thought it was going to be wrong, but it actually is true.
Yeah,
I think
so-
that's a kind of a compliment.
You said that jokingly, and yet it is true. So
excellent.
when I was looking at C#6 for the first time with Noda time, I'm going to let you say something soon. Honestly.
Oh, I hope so.
I
I'd
went
like
through.
some ice cream delivered.
I went through and found everywhere that I could use expression-bodied members and got rid of half of the return statement. Expression-bodied members.
That was a Beyonce single.
This is an expression,
Yeah.
and it's the entire body of the member, which is a property here and a method here. So that's why it's called expression-bodied members. So I got rid of everywhere that I could that had a return statement in Noda time, and about half of my properties and methods I managed to make expression-bodied members. And the great thing is, it makes you feel like a functional programmer. And this is why because this looks like
I'm glad Rachel Reese is not here to call you out on that.
Indeed.
Bold
So,
statement.
this feels like it's Haskell now, honest. But no, it makes it feel a bit more functional, and if you're a fan of functional programming, but still writing C# rather than F#, it feels a bit better.
Okay,
So,
so
that's
delete.
hence it looks a bit smarter.
Okay, so delete those. Go back to
yeah.
judging the person that wrote the
Right.
question. So
So-
those are wrong.
These are a waste of space.
Waste of
when
space.
you could just use dot notation,
Really?
people call it, or lambda notation. These compile to exactly the same code.
But I find those to be kind of cooler because it feels like you switched into another world and you're writing SQL, but not.
Right. So there's nothing actually wrong with it. It's
Okay.
just it feels a bit of a waste.
Okay. And it
if,
can't, yeah.
if you just have a where or just a select or even a where and a select, I would typically use this notation.
Okay.
As soon as you use joins or let clauses or anything that uses what's called a transparent identifier, where the compiler starts building up anonymous types for you and doing cunning stuff so that you can have multiple. This is called a range variable. Okay. Anytime you have multiple range variables in scope at the same time, usually from joins, also from J in db.jobs. The compiler's doing stuff so you can access C and J at the same time, even though it's one sequence. At that point, it's a pain if you're doing it in lambda expression
I gotcha.
format.
Okay.
It all works because the compiler is just doing a syntactic transformation from this to the other format. But it's definitely worth being familiar with link in both notations.
Okay, so you,
Yes.
you draw it like that. It makes a better question.
So now I'll just cancel this.
What is the difference?
Right, so back to IQueryable and IEnumerable. Why don't you take it from here?
Okay.
Okay,
Let me flip over.
switch. We brought this this mainframe here to help us understand Jon Skeet.
It's advanced. The first thing I want to do is drill into what is the difference between IEnumerable and IQueryable, really. And so let me back up for a second. I have, once I zoom out, some movies here that are from an IEnumerable data source. An IEnumerable data source just being a list of movies. And I just want to show you how the link operators
the list
work.
Of 2 good movies.
2 good movies. Well, yeah, I threw that one in.
And then Swordfish.
Because
I'm very glad you said that.
Thank you.
I knew you had blogged about it years ago as one of those movies that had questionable technology in it.
It was not Mr. Robot, let's just say.
If I can get this on the screen, what I'm trying to show you is that the link extension methods, the link operators, they're composed of a series of extension methods that are extension methods for either IEnumerable of T or IQueryable of T. So if I have something that's an IEnumerable data source, and I go up and do a dot on it, trying to get this all on the screen at once.
There you go, that looks okay.
We can see that I'm working against something that takes a func of T source and int, or sorry, let's do the first one. A func of T source and returns a bool. So basically the where operator, I have to take some incoming source, return a bool. From that function has to return a bool, and then the where operator itself returns an IEnumerable. And just to switch that over real quick.
That was really confusing, by the way.
Yeah, well, I'll make this one more concrete. The important part here is that if I go to movies and make them queryable, so this is kind of magically making them queryable for a second.
So you're looking, to be clear and make sure I understand, because I don't understand. You were looking at an IEnumerable thing.
Yes.
And then you were looking at the where and what where needed.
Yeah,
Where being an extension
right.
method that gets spot welded onto an IEnumerable.
Yes.
Yep.
And now you're looking at the same where
Yes.
on IQueryable, and I noticed
Exactly.
that it's got more stuff.
More stuff, and the most important part here to notice is that now I can no longer take just a func of T source and bool. I can take an expression of func. And that's the key part. It's func versus expression of func. That's one of the key differences between IEnumerable and IQueryable.
When you say func, I don't feel smart.
Yeah, well, so let me show you. A func is a type. Let's do this. Let's run some code. If I build a func,
I just need to know if it's okay to not feel smart or if I need to know this.
func
You
was
need to
introduced
know.
into C# as an easy way to describe a delegate. So func takes from 1 to 16 generic type parameters. So the IntelliSense is beautiful, right? But basically with a func, you're talking about
Yeah, that seems way better.
generic type parameters.
Of
where
any
the-
type.
So I'm going to declare a variable that's going to point to a method. Let's call it foo. The last generic type parameter always describes what that has to return. So I have to return an int. And all the type parameters that come before that describe the parameters that I'm going to receive. So I have to take 2 integers. and
Okay, so
return
hang on,
them.
let me see if I understand. So the last one is always the return type.
Let's make that a string so we can easily
Yeah,
tell
make
the
that a string.
difference.
Yep.
So this is any function
Yes.
that takes 2 ints
Yes.
and returns a string.
That's correct.
And it can be called whatever.
Yep.
Call it anything.
Okay.
Yep.
And
So
it's just a delegate.
it's kind of like an interface, but it's not. It's just an agreement that you hand me a function that does 2 ints and returns a string,
That's
and that's our
correct.
agreement. It's not,
And
it's not a
in
formal
many
interface.
ways, a delegate is like a single method interface. So
a single method interface.
yeah, they have a few other funky things like being able to do
Funky things? Sorry.
So you can do begin invoke and stuff, and you can combine delegates together, but the guts of it is it's a single method interface. So if you imagine that func were ifunc of T0, T1, T result, it would have a method saying invoke that took a T0 and a T1 and returned a T
Yeah,
result.
I think that we, the normally brained, feel overwhelmed when we hear people talking, I don't know, in the hallways or whatever at work, and they're like, oh yeah, you just take a func of an expression of T and you return a T of whatever. And it's like, whoa. I know I'm not the only one that thinks that. I'm just the only one that says it out loud. Everyone else just wants to keep their jobs.
I think that being generic doesn't help on that front as well. So,
Yeah.
you know,
Yeah, all
cool.
the generic type parameters.
Okay, so that makes a lot of sense. I think that right there, that's the kind of, like, take a screenshot and go home and study that. You know what I mean? That's a really great example. That one right there, your ad. So
Right.
thank you for
Yes.
that.
and that's using a lambda expression to sort of declare a method in line, but equally Scott could have created a method that had the same body and
Yes.
say, hey, create me a delegate that
Right.
points to this method.
Okay.
Yeah, I could have pointed it to
So
some method. Right.
the where that comes off of or hangs off of IQueryable is a lot more sophisticated, allows a lot more flexibility than the one that hangs off of IEnumerable.
So they're sort of duals of each other.
Okay.
We've talked about the one from IEnumerable, which is a delegate. So that's, I've got some code. I can execute the code.
Okay.
Yes.
Then there's expression of some delegate type, like func in this case.
Yeah.
And that's an expression tree,
Okay.
which is not the code, but a description of the code.
Okay.
So it's code as data.
Yeah. So what's important here is that if I have a func and a variable called add, this is still compiled into code that will execute without me doing anything. So I can just invoke add.
And
Right.
the compiler will have generated IL directly into the assembly. It will be there as if you've written the method yourself.
Okay, so
Yeah.
to be clear, the instructions that represent the adding, or in this case, the concatenating of those two things is compiled, and it's compiled ahead of time, and it's
Yep.
available to be called like any other function out there in the world.
Absolutely.
Okay.
Yes.
It's not being, the execution of that thing isn't being deferred. It's just simply a funky way of describing a function.
Right. Although execution is sort of deferred in that you're declaring the method.
Yeah.
You're not executing it immediately until Scott calls add.
Right,
You're
of
not
course.
calling the method.
Understood.
So we'll talk more about deferred execution in terms of link stuff
Right.
in a minute.
Okay.
Yes.
But the difference here is where Scott's got an expression of that. In fact, why don't you add a console.writeLine add e,
Yes.
and then we can see the difference. So
Let me comment out this line.
Yeah.
You see, we can no
So
longer
you're doing
execute
a
that.
console.writeLine which does a implied toString
Yep.
on a
an expression,
expression
of func of int
func,
of int
as
string.
Can you do a write line on the func, or just the expression?
So, yeah, you can. It's
You
just,
can, and it will give you the name of the method that the compiler has generated for you behind the scenes.
Maybe do
It won't be
console.writeLine
useful.
on each one.
Let me just
Yep.
call it, let's just go back to add for a second.
Okay.
And I'll show how we can get both here.
So you've got a func that takes two ints and returns a string. He does a toString on the thing.
Right.
Oh, and actually,
And
yeah, sorry,
and it
hasn't-
looks like a, yeah, and that's
It's
the kind of
just a
stuff
func
that we
object.
see in the call stack sometimes.
Right.
So it's not, func doesn't override to string. So it gets the exact thing that object.toString gives you,
Right.
which is just the
And
name
that,
of the
that kind of
type.
makes sense, though, because that looks like a function signature that takes
Yep.
those two things.
Yeah,
There's
the-
no information about what it's going to do.
Right. There's no information about what it's
Right.
going to do.
And that's
Right.
really, really important.
And the important part is when you wrap a func with expression, you're no longer generating executable code. You can think of the C# compiler creating a data structure that describes the code. So I can no longer, at this point, invoke add. That's not going to work.
Can I can't invoke it?
Not yet.
Not yet.
Not directly.
And this is how technologies like Entity Framework and Link to SQL work.
Right.
You feed them expressions, and they look at the data structure and see that, oh, you were calling .where and .orderBy and .select. Let me translate that into SQL. It's an easy way for them to do that. But one thing I could do here is I could strip off the expression part of this and get back a func of int and string once my fingers start working. Let's call it add e. It's add executable by walking up to add and telling it to compile itself, compile that expression. And that would actually give me code out. So now
So
if we,
then a func pops out of compile.
yes, exactly. So if we console.writeLine, aha,
IntelliSense.
yeah, CW for
Intel.
console.writeLine, CW, there we go. Let's write line both of those. Let's go ahead
There
and
you go.
execute. You know, that's legal code. Run this. So an expression gives you a very rich description of the code that you wrote.
Yeah, it basically gives you the code back almost.
Right.
Yep.
Whereas just having a func is an opaque block of compiled code. You know, all I know is it's a function that takes two integers and it returns a string.
So you can't go in the other direction. You can't take a func and build an expression tree from it. And you could build an expression tree that just calls the method, but that doesn't give any information about what's
Okay.
in there.
So let me see if I've been paying attention, because I may get this wrong. Does that mean that IQueryable can take funcs then, and IEnumerable takes funcs, and IQueryable takes expressions?
Bingo.
That's the big difference.
And the reason that we saw when Scott showed IntelliSense of where on an IQueryable, you saw 4 things instead of 2. That's because IQueryable of T inherits from IEnumerable of T. So you still get to see the ones that take func, but you can kind of ignore them for the moment. If you're using IQueryable, you want to be using expression trees. And in fact, if you don't use expression trees, if you have, let me edit this again. So
Switch over to him.
yeah. So if we had IQueryable customer all customers. I don't know why it's scrolling down. That's very, very weird.
That
I
is,
suspect
that's
it's
your company's browser, so.
it's your company's hardware and your company's operating system. So if we did func customer predicate, is predicate a familiar word to folks?
I know it's English.
It's something that judges whether or not, it's like a filter. Let's call it filter. It's
the where what
Yeah.
equals what part, right?
Exactly, yeah. So it's something that you say, does this match the predicate or not?
Right.
Yeah.
It's a matchy expression, you think.
It's a matchy expression thing.
I really feel like I'm providing value.
The downside about using the term filter, I found when writing code, is a filter sounds like it's something that removes things, whereas a matchy expression thing is something that matches things. It's a more positive thing, and we want to include everything where...
It is better to be more positive.
Yeah.
That's why I say affirmative at work. It's much more positive.
So if we have, suppose we weren't caring and we just did matches equals all customers dot where matchy expression thing.
Okay, so that's where you would ordinarily put that thing, and then you just broke up what could have been one line into two.
Right. And my reason for doing that is to show something that's bad. So the fact that IQueryable of t extends IEnumerable of t means that this code works,
Yeah.
but it's not doing the same thing as if I had the expression version. They behave radically differently.
Right, because that one, you've pulled back. If you haven't released the arrow yet, you've kind of had it held there. You have,
Well,
until you
in
say
both
compile.
cases, they're held. So these are both deferred. So executing either of these bits of code will do nothing. It will
Until
not
the
hit
where
the
happens,
database.
right?
Until you start using them. So
so
var count,
You're
for
saying
example.
even at the point where you say dot where and you pass it in, it's still waiting for you to go to the first one.
Exactly. This is creating a query.
Okay.
And it's not until you need some results. Link is lazy. It will wait until you need some results before it does anything.
Okay.
So if we do matches.count and matches.count there. Okay.
Yeah.
So these now look, these are no longer deferred.
Are they identical in their behavior?
This one is really nice. This one will, entity framework, I'm assuming this is entity framework or something similar, will say, do you know what you want to do? You want to call execute scalar of from customers where customer.city equals whatever. And it will do all the work on the database and return you an integer. This version will say, OK, you've given me a func, a delegate. I will fetch all the customers from the database all the way to your local machine and check whether each of them matches against the predicate you've given, because, hey, you've only given it to me as a delegate. I don't know what that means. I can call it, but that's all I can do with it. And I will count how many match. So clearly, this is bad news. You don't want to call the enumerable stuff on IQueryable, usually.
But that sounds like the kind of thing that people do all the time, and then they complain about .NET sucking.
I would say not all the time, because normally you're using one of these, or you're doing it all in. If I did where c goes to c.city equals
That would
city,
do the right thing.
then that would do the right thing, because overload resolution would say, hey, it's an IQueryable of t. There's something in IQueryable that works with this. I can convert. So interesting, slightly nerdy, interesting thing about this. This expression has no type. Okay? It's a lambda expression. It doesn't have a type. It is convertible to a func or an expression of func.
Depending on your
things.
needs.
Indeed. And overload resolution says, can I do anything with IQueryable? If I can't, I'll go up to IEnumerable. But hey, we can do, this will work with IQueryable because I can convert this to an expression tree. Yes, it will then do the right things. In other cases, if we had something in this case, it will look and say, is there an IQueryable method that takes a func? no, and I can't convert from func to expression of func. So, okay, I'll look at the extension methods on IEnumerable
I'll
instead.
do it in the only way I know how, which is bad.
Exactly. I'm going to cancel again before I accidentally save the changes.
Do you have the power to do that? Like, are you like is there like a super user world that you live in at Stack Overflow?
It's not that super user. I think.
You
anyone
just
know
said
what
you
the-
can't hit save because it'll be bad.
Well,
That means you have the power to change that question and rewrite history.
Most people, it's like 3,000 or something to edit without. Anyone can try to edit this, and then someone else would say, "Oh no, no, no."
Oh, no.
I do not think so.
I just broke 3,000. So
Well,
I
there we
think
go.
I
So
can
you
do
could
this
probably
too.
edit without anyone looking. Other people can roll it back, of course.
All right,
Right.
cool.
I'm not sure whether we've answered this or not.
I have no idea.
Yeah.
What the way that I think of IEnumerable, though, is that if you're just going forward, then use IEnumerable. And if you really have to ask hard questions, use IQueryable.
If you just want to go forward and want to look at everything that you get,
And look at everything that you get.
then
Okay.
yes, IEnumerable is the way forward. But it depends. There can be times where you want to split something and do some work because it's work that can be expressed in SQL with IQueryable, and then you can have an call .asEnumerable halfway down to say, right, don't even try to convert the rest of this into expression trees because SQL's not going to handle it. So say you wanted to find all the customers who have a hash code of 0. Okay, well, get hash code doesn't exist in SQL. It's a fairly meaningless question,
Right.
but you would do it
You have
by-
to run it on every single one.
Right. So there, you might want to do all customers where the city is city and has a hash code of 0. So you would do .where the stuff with the city, .asEnumerable, run the rest of it locally, and then .where again for the second pass of the filter.
Gotcha. Last question. Who is Stack Overflow user?
Oh, I know. He's got 6,000 rep.
Is that a person?
Yeah.
Or is
just
this someone who got deleted?
No, they're just someone without much imagination.
But how come they're in the top 6% of Stack Overflow, but they haven't been seen in 4 years?
Because they asked 109 questions, some of which are, I suspect,
That means
quite
that in the context of Stack Overflow reputation, long tail is long.
long tail. So the question that we're looking at has 635 votes.
So this question
that's
is
3,000 rep to start
it's
with.
buoying them all these years later.
Oh, yeah. I mean, the question that has, I don't know how much rep it's actually netted
What's
me.
the
'cause
best question on Stack Overflow?
The best question, we can search by
Like
votes.
of all questions of all time,
Why is it faster to process a sorted array than an unsorted array?
because it's already sorted.
But process, as in, so all they're doing is summing it.
Did I get reputation just then? OK. Do you want to answer that question, or do you want?
No, hell no. No. It's been answered with something that's got 21. This is Eric Lippert, I think. It's long enough.
You
it
keep
could be
going.
Eric.
You're
No,
going
it's
to find
not.
pictures
It's
of
not
kittens
Eric.
or something.
Eric's got some fantastic answers.
Eric Lippert?
Yeah.
Yeah. All right, cool.
Right.
So that was one question in a half an hour.
And I
Right.
still had one more thing to say.
Oh, please.
Go.
If you don't mind.
We'll just
Yeah.
have the whole thing be the one question.
So, in a way, I thought the question was kind of the wrong question to ask also, not because of the difference between IEnumerable and IQueryable, which we just spent, 45 minutes on. And we have 5 more questions to go or something. But it really depends on the operators that you're using. So IQueryable, IEnumerable, they can both offer you lazy evaluation or deferred execution. It really comes down to what operators you're using against those interfaces. So if you go to the MSDN documentation, every single link operator will have a description of its behavior, and it will say this operator offers deferred execution if it's a lazy type of operator or not. So just to demonstrate that, I just want to show you I have a link query here that's going against IEnumerable, and I'm using 3 arbitrary operators. None of them really have to be there, but I'm going to filter something, I'm going to take just 10 results, and I'm going to do an identity projection, right? So 3 different link operators. But I just want to find out, when is this work actually being done? When is the ID of a movie actually being interrogated to see if it's less than 100? And I'll do that just by having a console.writeLine. Hey, we're reading the ID, right? So now back out in the program, let's just get all the movies. And here's the key. If I see start for each, execute, if I see that output before I see that I read the first movie, read the second movie, read the third movie, right? That means none of that work was actually done when I called get all.
So get all was just, again, pulling back on the arrow, but didn't actually let go.
Exactly.
It's not going to happen until I for each. So if I run the program real quick, I can see, yes, I'm starting for each, and then I interrogated ID of 1. That was Star Wars, ID 2, ID 3.
So the get all didn't really do anything other than get ready to get all.
In a sense, it's also sort of building a data structure. It's building a state machine that's going to execute when I start trying to pull things through. Release the arrow. And notice how that output is interleaved. So we looked at the first movie's identifier, and that movie got to go the whole way through the processing pipeline. I got to write it out. And then we looked at the second movie, and it passed the filter and all of that, and we wrote it out. But then things changed, so I can still return IEnumerable here. But if I use an operator like toList, if you look in the documentation, it does not offer deferred execution. It's what we call a greedy operator. It has to produce a concrete list result.
Or materializes the results, is another thing you may hear.
So the output here is greedily, we went through, we looked at every single movie, put everything together, and then built a list in memory and handed that back to iterate over.
So does that mean that if we were using Entity Framework or something like it, and we were not thinking, and in some place we did toList, and some place we didn't, we would affect our performance and might not even realize it?
You absolutely could, yeah. And I've run into that problem in big web applications where developers will do a toList because they know they'll force it to execute, but then they'll do a toList and pass it to someone else who does a toList, and just kind of carries on. The other thing to be careful of is there's another category of operators. So let's get rid of the toList, and I can see that I'm doing sort of the least amount of work possible here. I start the for each, and then I look at the movies. But let me add an order by, and let's say we want to order by, given a movie, we'll order by the movie title, the default ascending order. And the output now will be slightly different. So we're still deferred.
It had to go and read everything to do this.
Exactly. We still didn't do anything until the for each tried to execute. But once we tried to pull that first item back, order by is known as a non-streaming operator. It's not allowed to stream data out. It has to go through the whole thing.
Which would explain why it's faster to process a sorted list.
Exactly.
Call back.
And with that, I'm done.
I was going to very, very quickly just demonstrate
I love that
something.
the whole time he was talking, Jon Skeet wrote an entire program.
Yeah.
So it was just, Scott was demonstrating, doing a bit of diagnostic work, putting a console.writeline in the
property.
In a property. I was thinking, there's a nicer way of doing that. Not that takes a little bit more work once, but it's only the once.
I'm going to go to Stack Overflow. Is there a nicer way to do this?
So
You're going to write a log extension.
Yeah, exactly. So just to demonstrate how nice Link is, you mentioned you've got IQueryable of T and IEnumerable of T, and there's stuff on there. But there's also parallel query. There's iasync enumerable from system.extensions.async or whatever it is. You can write your own link-like operators wherever you like, and this is just a log method.
People don't do this enough. Like you just said kind of casually with a flip of the hand, you can write your own link operators.
Yep.
And everyone else in the audience said, well, you can.
But no, it's relatively easy, but you do need to sort of know what you're doing in terms of the. You took the photo before I put static. So you do need to know what you're doing in terms of avoiding being greedy when you don't need to be, and documenting sort of whether it will be greedy or not. So we now have the main part of the program is we have a get all that returns movies. We've got Forrest Gump and Big. I've got a where filter. Then I'm just going to log what we get to in this pipeline. So I always think of Link as a big pipe.
But to his point, he said, well, this is a greedy operator and this is a non-streamable operator. What did you make?
So this is a streaming operator.
Okay.
So this doesn't do anything. This is using yield return, so iterables in C#. So this creates a new sequence. So even though this method will be called, when this method gets called, it won't do anything. It will prepare another arrow. And when it gets asked for its first item, it will run just until the first yield return, and then say, hey, I'm done for the moment. Here's some data. Kind of put me on pause.
In the middle of the for loop.
In the middle of the for each loop.
It's returning stuff on each iteration.
Yes, and it sort of dives back into the middle of it.
Okay.
And I don't know whether we're going to have time to get to await, but await does exactly the same kind of thing. It's actually building up a state machine behind the scenes. Yeah, it feels unlikely at this point.
It's fine. We're only on question 1.
So if I run this, what I'm expecting to see is that let's put something to make it obvious that we're logged.
Yeah, that you're in there.
OK.
So logged comes out of your operator.
Yeah. So we expect to see logged from this.
What if you put in a console.writeLine in the way that he did it in the property as well?
In name.prop in the name?
Yeah, to see what happens when.
Right. So then we would see. This is OK.
Are you upset?
It means I can't use an auto prop anymore.
Yes. That's true.
You really like those.
I do. Especially now they can be read-only in C# 6. I've only been asking for that feature for like 12 years, along with using static. To be fair, everyone knew that having a read-only autoprop would be a good idea. It's just they hadn't got around to it. OK, so now we're expecting. So let's write prop name. So I predict that we will see prop Forrest Gump, then prop big, logging big, and then just big when we get to, and nothing will happen. I predict this is the first line of the output. OK? So I predict this first line of output, prop Forrest Gump, prop big, logging big, big.
And why? And you don't get logging on.
I don't get logging on Forrest Gump because
the where is ahead of it.
Yeah. OK, so let's see whether I'm actually right.
He has to ask.
That if he's right.
Ooh.
We have bangness. Why? Name equals value.
That may be the only time that ever happens.
There we go. Right. And I've got. I've done console.
Windows plus.
Oh, Windows plus. Windows plus.
Windows minus.
It's lost the. I think
it's a
run it
tab
again.
back to it. Oh,
OK. Windows plus.
You can alt tab. Did you not stop running it?
It stopped running it when I hit Windows plus for some
That's
reason.
super weird.
That is kind of weird.
Well, that's OK. We'll just do it in our minds.
Yeah.
Oh, because it's reading the key that you push. You said read key and not read line.
I didn't do either, actually.
Why did it stop? Oh, it said press any key to end, yeah, because it's a console.
I'm going to just have a couple of those. When in doubt, add more.
That's the right number.
It's fine. Right.
Just minimize
magnifier.
Yeah.
That's fine, right?
Yeah, there we
Is
go.
that now readable?
Close
OK,
enough.
so that would say big.
It asked for Forrest Gump 3 times.
Yeah, do you know what? I put the where operator the wrong way around. I meant to make it only do short ones. It's done only big ones, but not big, because that's short.
But
This whole doing things off the cuff is not good.
But still, you were right.
If we do less than 5, and if I change it to not print Windows minus, right, instead of query, we should print name. In loop. Obviously, I would normally use interpolated strings.
I knew you were thinking that. As soon
Interpolated
as he
strings are
went
lovely.
plus, I was like, well,
Yeah,
shouldn't you use a string builder?
that's old school. No, you wouldn't want to
I
use
was a
string
joke.
builder.
I know. It was a joke. I was trying to make C# humor, but it didn't work.
So yeah, so predict first line of output. We get the property call for Forrest Gump. We get the property call for big twice, in fact, because the logging bit needs to fetch the name in order to log it. Or the to string does.
Yep.
And then we fetch the property again, because in the loop we need to call to name to get that. And we're there. So the main point of all of this, which I think we've somewhat lost, was that you can write your own extension methods.
Yes.
I have a segue. Not sort of a zooming
You have
around
a segue.
I have a
Are you
segue to the
going
next
deeper
question.
into the stack?
No, but another extension method that you can write that I won't write now is a static t
Yeah, don't write it or
random.
anything.
So you can write this so that it returns you a random element of the source whilst only reading it once and without taking any more, just taking a size of 1. You keep the idea of my current thing that I'm going to return, and you keep a track of how many you've already read.
And then yield on the random one.
No, you don't. Oh,
Oh, darn it. I got to write the whole thing now.
I won't get this absolutely right, but I'm using a double here because I'm going to be checking against a random
So default
number.
of t says, give me the default value or the standard value, whatever t
Yeah,
is.
so
T
it
might
would be
be an
null
int, it might be a
or
whatever.
yeah, exactly.
Does that make sense, y'all? Okay.
So this is something you would not normally do. I'd normally pass in a random. So we're going to keep track of what we're going to return at the end, and there's our return statement. And we say the probability of replacing what we're currently looking at, what we would currently return, with the one that we've got in our hands. So are we going to do current is item? And we do that if the next double out of the random number generator is greater than, I won't say, make it less than 1 over count. So it becomes, for some reason, slash.
How about that?
You lost the slash.
I've lost my slash key.
Go to window run, type your slash, copy it in, no. Copy
Okay,
it,
the slash key itself
copy
is
it
working.
into the clipboard,
Yep,
and then paste
I
it
have
into
it.
there.
Okay, so who knew? So
I have no idea why you lost slash.
Yeah, that's very odd.
One of your extensions wants it really bad.
Yeah. It's probably like quick launch.
Yeah, it's possible.
So this is very cool as a way of iterating over the whole sequence and taking taking no more space than it needs. A bad way of doing this would be to call source.toArray or to list, and then saying, oh, right, I have to
And
pick
then
out of 10
picking a
things.
random one,
Yeah, and that would be terrible if you had 100,000 things in there.
This is actually a good segue. Let's skip over that one dumb question and go to the random question. And zoom in on this for me.
OK.
And by the way, did you know that there's a feature in, I'm going to push Jon Skeet out of the way. There's a feature called larger touch where you can say use darker, larger feedback. So then when your finger is up there, they can actually see where your fingers are
cool.
when you're giving a presentation.
Nice.
Cool.
What's this stuff over there? That was.
What's what?
I haven't seen this. Is this anniversary edition stuff?
No, that is the magnifier thing.
All right. OK. So it's gone now. Phew.
All right, we're good. Cool.
Cool.
All right, so this person is saying, hey, I'm migrating a method from .NET 1.1 to .NET 4, and they feel that the implementation of random changed. So they pass in a seed value, and given that same seed, random.next bytes is coming back with a different result. So if you scroll down a little bit, on .NET 1.1, they get those 4 numbers, and on .NET 4, they get these ones, and they want to know how to solve the problem, apparently to make random not reliable, predictable.
Make random reliable.
So, out of interest, before we say anything more, how many of you think it is a reasonable expectation that that this person had a reasonable expectation? OK. Out of interest, on Java, I think this would be guaranteed
OK.
To not be random.
to be not random in a particular way. So neither of these are random. They're both pseudo-random, but they're differently pseudo-random.
But so pseudo means not at all?
Pseudo means if you squinted it in the right way. So
Like the way I squint at Java. Pseudo-random, not at all random.
So a pseudo-random number generator provides a stream of numbers or whatever that looks random to the naked eye, but is actually, there's a word that I'm...
Not at all.
Predictable based on, it's
coming out of a mathematical algorithm, so
Yeah.
it cannot be too random, right?
Isn't there enough randomness in the world that they can just pluck it out of the air? I mean,
That's
there's
really
there's
expensive.
like quantum stuff. And
right. And
can't
if
they
you
just
use
grab some
secure
of that?
random, sorry, no, secure random's Java, it's crypto random.
RNG crypto service provider.
Right.
What? Switch over. Did you say orangey?
Yeah.
Oh,
Random number
RNG.
generator crypto service
I
provider.
thought you said orangey random.
This is what you want to use to impress your coworkers who still use just random.
RNG crypto service provider.
You tell them
this
you're-
is legitimately random.
Yes, yes.
And wouldn't it be nice
You
if
tell them
those
the
two
terrorists are gonna
implemented the
win
same
because we're
kind of
not random
interface?
enough.
Is this really random? Is this the kind of randomness we can't export to other countries?
Yeah, probably. So that will use a different, that can use different random number generators depending on your hardware. So some hardware has like a radiation detector in it,
Yep.
like mini Geiger counter that it can use to get genuinely random stuff.
Backing away from the possibly radioactive machine.
That's true.
Others might look at sort of heat signatures of the chip and try to
Seriously?
get things. Yeah.
You're not playing with me.
No, not at all.
I mean,
It looks at the heat signatures
Yeah.
of the
There-
chip.
there
You
can be-
breathe
as
on
a-
it, and it'd be like, and now it's differently random.
Right. Yeah. So how many of you use Putty? Out of interest.
Putty?
Putty. Yeah. So a friend of mine wrote Putty. Let's see
A
if I've
friend
got-
of yours wrote Putty.
Yeah. A chap called Simon Tatham, who works in ARM in Cambridge. He was my best friend at university.
Of course he was.
So if we want to generate, if I remember rightly, so look at this. Please generate some,
Some
use my
randomness.
newfound skills with Windows
Yeah, yeah.
Magnifier. Please generate some randomness by moving the mouse over the bar. So you do that, and it's generating entropy, so random bits.
Because no one would ever go and spin the thing in a predictable counterclockwise
Well,
circle.
It doesn't. How likely is it that it'll be exactly the circle, and a little bit of difference on exactly
That's
where
all
it
it
is
needs.
will be huge in terms of the result. So you generate enough, and it comes up with some stuff. And so that's human-generated randomness. But yeah, there are various sources of entropy within.
Right, but on a
different machines.
server, you have to go and figure out what's
Right.
random around us.
So back
Yeah.
to Scott's machine, RNG crypto service provider will use a good source of randomness
Why doesn't random just do that?
because it's expensive.
Yeah, this is like at least an order of magnitude slower than just using random.
Yeah.
Okay, so should we just not? Would we not use random? And
what
also, why
are you
does this
building?
person care? Like, why do they care that the number changed? Like,
So my
they must
guess
be doing
is-
something wrong if they noticed.
No. So
No?
it's what they're doing is they're providing a seed to random. So there's still this word that I can't think that's like predictable but fancier. Sorry, deterministic. Yes,
Deterministic.
right. So system.random is deterministic. You give it the same input, it will give you the same output. And that can be very useful in tests. So say you have a golden implementation, you're confident that something is right, okay? And it uses random numbers,
Okay.
and that makes it really hard to write unit tests for it. I want to check that if I change the implementation, I still get the same output.
Okay.
So I need a predictable source of random numbers, and system.random gives you that by having, here's a seed, it will give you the same results every time.
So if I
Until
run
you
that
change
person's
version of the
app,
framework.
if I run that person's app on my system and give the same seed, I'll get the same random numbers.
Uncertain. So it depends. Shall we see what,
Yeah.
You see what I'm saying?
That's where it
system.random
becomes-
does?
Then
Yeah,
it's
that-
like, well, wait a second. Are we generating random numbers? Or are we just like counting up through pi? You know what I mean? Where it's
So
just like
it-
start marching forward a million numbers and we'll all get the same values.
So system.random will take the seed that you give it and probably expand it into a bit more state. So I think it only takes a long, and I think random has like 128 bits or 256 bits of state. And then every time you call next double or next int or whatever, it spits out a number and moves on to another state. And we should all get the same results from at least the same version of .NET.
The way I
And
think
is-
about it is that there's this universe of a series of numbers,
Right.
and your seed picks one of those series.
Okay. And is this, for lack of a better word, is this okay? Like, because I see people complaining, or they're complaining about .NET, or complaining about Java, or complaining about whatever, about behaviors like this because they think that the class called random should return random stuff. Is that just showing a fundamental misunderstanding about how these things work? It is okay that apps, that programming languages and computers work this way, right?
Depending on what you're building. If you are building a betting site, do not use random.
Right.
Okay? If you're doing anything where someone has financial or security gain from being able to predict the next number, then you do not use random. You use RNG crypto service provider.
And I presume that there are probably, and I'm extrapolating here since you already made up that whole story about how the heat of the thing, which I believe, but still I don't believe you. That means that there's probably like random number generating cards that I could buy for my casino that would be like hardware accelerated random number generator thing.
Or
that must exist, right? Because now that I've learned all about how random works.
I think so. And random, if you don't provide a seed, it will just take the current time.
Does that mean that their seed could be better? Is there a seed that you could pull out of thin air that would be better if you had like a sensor or something?
You could get a different seed, but the point of something like RNG Crypto Service Provider is it doesn't use a seed and then a predictable sequence. It says each time I will do something cunning to get genuinely
10 times or more.
So you can genuinely not predict the next one from the previous one.
And it's a lot slower.
Yeah. So it turns out MSDN confirms this. This is the constructor taking a seed, and this is often done when testing apps that rely on random number generators. Hurrah!
Would that be fair to say then that really no one should be using random except in their tests?
No, because you would use random for something. If you've got some little game that you're writing that really doesn't matter too much.
You see how you're not just saying yes, Scott, you're right. You're saying it all depends.
It depends.
And the examples that you're giving are if you're doing something trivial that randomness doesn't really matter, use random. If you're serious about randomness, use something else like RNG.
If the randomness has a really important effect. So anything to do with security, heaven help us, anything to do with safety, although safety and randomness don't tend to go together, and definitely anything to do with money, then you do not use random. But for a game, so games are interesting. So people do put money into games. So Pokemon Go, I would probably not use random. He's catching them as we're. This is just disgraceful.
I know.
No, I'm not really catching them. It's all Zubats around here.
We had to go catch him before we could get him into the room.
Pretty true.
How many things did we throw at him before he finally hit him? But so if you've got a single-player game and there's no in-app purchases and no one's going to be trying to game it, as it were, then sure, random's fine. And certainly if you're trying to, say, load test something, and that's another interesting example. If you want to write a load test and the input to your algorithm may well affect the output, so it may well affect how long it takes to do something. So, for example, if we generated a random array and then tried to process it, then as we know, it would be faster if it's already sorted.
Exactly.
So if you happen to get a random sequence that's already sorted or mostly sorted, then you could get different results out. So again, if you provide a seed, then it may not matter what that sequence is, so long as you get the same one next time you run the test.
Do you all want to see if we can do the tail call question in the last 5 minutes here?
Yeah, let's wrap this up by saying it's slightly unusual that random changed behavior between .NET 1.1 and .NET 4.
But maybe we don't know if they
not
went
too
from
bad.
32-bit to 64-bit. We don't know if that's a...
It's sort of, that's an implementation detail.
And we could look
whereas
at the code, too.
We could indeed. Well, we could look at the code now. We couldn't look at the .NET 1.1 code. Well, I
yeah, you
couldn't.
can. Isn't it at source of .NET?
What, all the previous versions?
Yeah, isn't it?
I don't know. Anyway, let's move on.
It was all source opened before, remember? Like there's
Well,
zip
there was
files.
the reference source, but
Yeah,
that
that's-
wasn't.
that's
yeah,
the
that was. Here's a version that we could have shipped, but we actually shipped the version over here,
No,
which could be.
To be clear, reference source is the real source. They
Okay.
stripped out the swear words in the comments, but it's the real source.
Okay, because there was definitely a version that shipped like.
There was
.NET 2.
a cleaned up version
Right.
10 years ago, but
Yeah,
this is not
which I
that.
think they also called reference source.
Yeah,
Just
but
to
there's a
confuse us.
website called sourceof.net
Cool.
that's got the real source, and they update it.
Right.
Cool.
Fab.
Yeah, we could either do that or just, we only have, what, 3 minutes left?
We have
So,
4 minutes, 3
yeah.
minutes. What do you
could
want to
go.
do? Let's do tail call. Is that okay?
You want to
You want to do one more question?
Okay.
Unless you want, do you need to go?
No.
Is
no,
that okay?
No.
All right, let's bring up that one.
So, yep.
So why doesn't .NET or C# optimize for tail call recursion? Of course, that begs the other question, what
the
is
hell?
tail call recursion?
Now, to find out what tail call recursion is, you call something that gives you tail call recursion.
That's like that episode of Star Trek where they're like, I cannot tell a lie,
Yeah.
I'm lying.
This is why I didn't
must
want to
go
do
deeper.
this. We're never going
Exactly.
to get out of the room
Right.
now.
So right here, they've got a function called foo that does some stuff and then calls itself. So this is a classic kind of recursive recursive function, and then you would expect to look at the call stack, and it would go super deep. And 15, 20 years ago, I would blow the stack because
Right.
I've gone too deep. And
You
that's,
probably would now.
How deep can the stack go now?
I suspect not that deep.
I think
Let's
it's
find
a
out.
4 megabyte stack by default, I think. in
Which would be
.NET.
just about right for this
When
particular
I was
method.
doing Palm Pilot, we had a 2K stack. We
Machines
broke
are
a
bigger
real-
today, fortunately.
What's that?
Machines are bigger today, fortunately.
Right. So let's call foo 0.
You just pasted that code directly from Stack Overflow into production.
That's what I do all the time. Right, so this is going to call foo0, so it's going to recurse 1,000,000 times. So if we have a 4 meg stack, given that all it needs on the stack is an integer, I don't know, it might need 2 ints, one for the result of I+1. Who knows? And
We're going to see if we can blow the stack here.
building, bang, Stack Overflow exception.
Yeah.
The irony that you just pasted from Stack Overflow. That's actually pretty awesome.
OK, so tail calls mean that that won't blow. Are we done?
So hang on. Optimizing for tail call recursion, would that not mean that we didn't need to go deeper in the stack? We could just kind of go sideways.
It should be the C# compiler being able to look at that function and saying, I see the last thing you're doing is making a function call to yourself again. So let me just reuse the same stack frame that I just created, thereby not continually allocating stack frames. So
Exactly. So thinking of stack from the bottom this time, you can think either way. So here we have foo of 0, and then foo of 1, foo of 2, foo of 3, foo of 4, etc. Something it can be optimized with tail calls if you can say, right, foo of 0 calls foo of 1, but I'm bored with this stack. I'll just put foo of 1 on the same thing. Foo of 2, foo of 3, foo of 4. And then, so this is a method that returns void. We could return I. And either way, you can just say, well, do you know what? We don't need to come back. We can just return the same thing. And a smart either compiler or runtime or both can notice that it can do this switch and just sort of overlay the new stack on top of the old stack, which is typically the case if either you don't return anything or if you return just the result of the recursion, possibly with some constant things, but
right.
I'll give you an example that doesn't work with this.
This is not doing tail call optimization, but
So it isn't, but it could be.
It could,
Right.
because they're
So-
saying, why doesn't .NET support it,
Right.
as if it doesn't at all.
Well, I think the CLR supports it, but the C# compiler doesn't do it.
Or it can do it in certain instances and not.
So there's interesting stuff here.
I'm sorry, are you banging out the Fibonacci sequence from memory?
Yes, it
Yeah.
is.
Just checking.
You know, this isn't how I would normally write it, but just for the sake of
Oh, this isn't how you would ordinarily write the Fibonacci sequence from memory?
I would normally validate my arguments and handle the
I would
base
ordinarily
cases differently.
I would ordinarily Google it and pick the first option, but that's okay.
So the reason that
You do
while,
you, Jon Skeet. You do you.
While foo can be tail call optimized, fib can't
But
because
foo wasn't though.
no, it wasn't, but it logically can be.
I see. Okay.
Fib can't be using this implementation because we make some calls and then we make some other calls and add the two together.
Yeah.
So if you've replaced, we need to keep remembering.
Because it's a tree of recursion
Exactly,
as opposed
and
to
at
a
every
straight
point you sort of recurse down, and then you've got to add the results together. And it's
Right.
the fact that you need both of the results that make it hard. There are other ways that you can implement Fibonacci that do it
And
iteratively.
Fibonacci ends, theoretically, right? But could you still blow the stack if it needed to go big enough?
Yeah, so if I call fib 1,000 here, it would probably actually take a
while.
it would eventually go down, and certainly fib 1,000,000 would.
So does .NET support tail call recursion or not, or just
Yes.
depends?
So the CLR supports a tail.call operation operator, but as far as I'm aware, the C# compiler never emits that. But also, the CLR can, in certain situations, spot that it can do a tail call, even if you haven't asked it to. And sometimes, if you ask it to, it doesn't anyway. So I think they fixed it in .NET 4 so that it would always.
It's kind of like CSS in web development.
So I think F# basically forced the CLR to do it properly.
So I'm looking at another question here that says that there are different levels at which tail call optimization is supported.
Right.
The JIT is responsible for
Yep.
the optimizations. The C# compile could use tail call, the
Yep.
IL opcode, but no version of the C# compile does this. It is the jitter who is permitted to make those optimizations. So you're saying the C# compiler doesn't do that.
Right.
Really, it's up to the jitter. It could do that, but in the chain of responsibility, as they see it now, the jitter.
Ultimately, it's
Could
always
do
up
that.
to the JIT.
Right. Well, ultimately, it is.
but,
the C# compiler makes a hint.
The C# compiler could give a hint. It doesn't at the moment. The F# compiler definitely does.
So it says that the JIT compiler is permitted to make optimizations whenever it sees fit, but only the 64-bit jitter does it.
Right.
And then there is a. It only happens in release build.
Yep.
Could you go and release? And see
I'm
if
just going to go and release build.
And there is a blog post in exquisite detail called Tail Call JIT Conditions from 2007 that literally has page after page of all the different scenarios where if everything's perfect, it'll do it, otherwise it won't.
So still in debug mode, but 64-bit. This is still going bang.
All right.
In release mode, let's see. Woo! Oh no,
It says
it
permit
got
30,
twice as far.
It permits. It says permit. It says
Oh,
prefer
sorry. Do you know
32-bit.
what? I thought I could have sworn I did that. Oh, I did it for debug, but not for release. Dom. Look at that! Woo!
Hey, look, tail
Don't
call
applaud me.
optimization.
Applaud the CLR implementations. But yeah, it works.
So it does work.
Yeah.
So we should go and edit that Stack Overflow question and tell that person that they suck.
Well, it's saying that it can. It's exactly right.
Well, hang on. Microsoft Connect. Let's just go into the belly of the beast. Answers should answer your question. What is the? Thanks for your suggestion. We will continue to look, but they already did it though.
No. So
Oh, this is 2013. Why didn't they just say, do it this way, and it would have worked? Are you going to write it at the command line now?
no. I'm going to see what the
Oh,
the IL
you're
is.
looking at the IL.
Yeah. So. Right. So it's still just using call. It's not using tail.call
So how did it work then?
because the JIT can still decide
The
to
JIT
optimize
did
it.
it.
It's a hint more than a.
But I guess what I'm saying
You
is
might
that
have
it
opened up
feels
the wrong
like
one, John.
the
Have I?
Stack Overflow question makes it look like it didn't actually happen.
No, that's the right one.
Okay.
So.
Are you
Did I-
running
oh, I
fib?
see.
Oh, you
Okay.
looked at you looked at the wrong method. Sorry.
Oh.
Foo. Foo. No, it's still a call.
Yeah, so to be clear, that makes sense though, because you're by looking in there, you're seeing if the C# compiler output it. That doesn't say that it works. The fact that it ran to completion says that it works.
Exactly. Yeah. So that proves that the JIT is able to optimize it even without tail.call.
Right.
I believe the JIT in 2.0, sometimes even if you make a tail.call, it won't.
Yep.
It's possible that tail.call is still advisory, but it now is more.
But it also has I think that another way to think about this is that it's a very visceral example of 64-bit being a good thing in this case, where usually I do things in 32-bit for like web apps, but release versus debug.
Right.
There's all these optimizations that happen. in
Because
release
if
versus
you're
debug.
in debug, and I suspect if we'd attached a debugger even to the release build, it would still, when you're debugging, you really want to see what has logically gone on,
Yep.
which is, hey, I've got these things on the stack. So you wouldn't want it to do the tail call thing there, unless you were trying to determine whether or not it was going to do the tail call.
Cool. We are now 6 minutes over.
We are.
No.
Let's give a big hand to Scott Allen and Jon Skeet. And many thank yous to Rob Connery, who has this idea and continues to do it, and to NDC for allowing us to waste your time for the last hour.
Thank you.
Thank you.
Enjoy your lunch.
Thank you.